Problem 4 is a little interesting. Um, you got triangle MRO. That's the big one. And they toss this at you. They try and intimidate you. Trapezoid PTRO. Like, you're going to be fooled by seeing this. You've seen this diagram how many times now? Like, whenever you see that diagram, you see, this is parallel to this. These are similar triangles. They're just trying to throw you for a loop and be like, hey, look at that trapezoid. This might be different, right? No, it's the same problem. So don't sweat it. Just treat it like the rest. And look, they put in all the information for you. They tell you this entire side MR is 9. That's my entire blue side. So I'm going to write that in as 9. They tell me MP, which is like my small red side, is 2. You tell me PO. That down there is 4. So, you know what? If you want to separate it, go ahead, separate it. I'm feeling a little bold. I'm not going to separate it. I'm just going to recognize that I have this small triangle here and then a bigger one on the outside. Here they want to know what the length of TR is. I want to know what the length of TR, this piece here. There's a couple different ways you can do this, and I'm actually going to do it both ways because I was inspired by Alyssa's method in class on Wednesday. So I'll do it the Alyssa method first. I want you to see that this 4 corresponds to that X. They're both pieces of that blue triangle. So I can make that a ratio. I can say, look, that 4 right here, that piece of that big blue triangle, that's going to correspond to this piece here, X. So I'm going to put that as a ratio. And I can do the same thing with my blue triangle. Or I'm sorry, with my red triangle. He'd be like, look, this piece up here, it's going to correspond to this piece right there. Okay. Well, I don't have that piece right there. So the way I would figure it out is I would do the entire length, 9, and I would take away this piece here. I'd have to erase it. And the way you erase something arithmetically is with subtraction. So it'd be 9 minus x. So I'm going to have 2 over 9 minus x. That already looks confusing. Like, you might even be a little unclear as to like where I got that. So I'll do it. I think the way that we have been approaching this is that you've got a small triangle there. This side is 2. So I'm just going to separate that. I'll put it here for now. And then you got this big old triangle. This entire side is 2 plus 4. It's really 6. And that's going to correspond to 9. So, boom. Okay, you can make a proportion to solve for x. And what we have to be clear about is if we solve for x, I'm going to call this y. Call that y. Because in this problem, this is what we were calling x. TR is what we were calling x. So I'm just doing that to show you that we'll eventually get the same thing. So if I use these similar triangles, the proportion I would get for that would be 2 over y, which is the same as 6 over 9. 6 over 9. I'm going to put these over here. And then I'm going to solve. So let's do this one. It looks easier. That'll be 18. That will be 6y. Divide both sides by 6. Y will equal 3. And what that means for me is that this piece up here, that is only 3. All right, you have like a triangle 2 and 3. And since I know this entire piece here is 9, I can say, oh, this 9, take away that 3. That will give me the x value. That will give me 6. So the length of TR, according to this, should be 6. And if I do this more complicated one, if I actually do that multiplication out, we'll get the same thing for x. And it's important to see that here I'm calling it x because I used TR is what I'm looking for. It's a different thing than the other one. And you'll kind of see how it works out. We're going to have 4 times 9, which is 36. And let me show that multiplication. 4 times 9 is 36. 4 times minus x is minus 4x. And that's going to get multiplied by 2x. So 2x. I'm going to add 4x to both sides. I'm going to get 6x equals 36. Divide both sides by 6. 6. X equals 36. And here, x equals 36. X equals 6. And here, I said x was representing that side TR. So since I set up my proportion appropriately, since I said, oh, that entire blue side, oh no, I said, how did I say that? Oh yeah, no, I did say that. I called this green piece here X, I called this piece 4, and what I was comparing that was to the piece up here, which is 2, and we didn't know what this piece up here was. We all we knew is that it was the whole take away that piece. We knew it was 9 minus x. So when we solve for x, it's telling us that piece TR is really 6. So pick and choose whichever one worked for you. Go with that one. If you're not sure, ask me a question. I'll clarify for you.